Okay. Welcome back to Wickerson Studios. We are now beginning, after a little intro, the intermediate advanced section of the ghPython one-liners within the ghPython remote node for Grasshopper in the 3D Rhino environment. We're going to take you through a few notes, talk a little bit more, and show this one example of linear regression following its base. The first thing to remember on this is get into your ghPython node as much as possible. Remote node, learn about the locations, learn what you have to type in depending on what you've downloaded. Make sure you're up and running in Amazon. That's the real trick. When you get onto here and you open a PowerShell, you've got to be in there and have that up and running. And then you're going to want to load in like pip install, however you need to get in, matplot library, numpy, whatever. You want to do that after you're actually running in. If you take a look here, do I have any errors on this one? Where is it? You should see from the beginning. Oh, I have lots of stuff here that I was working with in that server. Well, it's all still kind of a command line nightmare for me to figure out, but there's lots of sources online on what you have to go into and type in and get these things up and running. I can break it down for you, but it's taken me this long to get them all in and opening. And when that happens, and I've managed to get numpys, pandas, the only thing I'm not doing is getting a few. I think I can figure it out, but I get a few functions and methods running out of pandas, and I'll be a little happier. Might have to bring in things like this numpy and what I did in matplot library, but I'll figure it out slowly. It's working well with scikit learn right now, and I'm pretty happy with that. The base script that I'm using is this one, which is actually fairly nice, and this is in Python still, so anybody can just kind of cut, paste, and copy this. I'm opening up everything, Rhino script syntax, Rhino context, script context, ghPython remote, and then I'm using all of this format of this sticky to get those names through that node to run everything, and that's something you have to do, I guess, with the ghPython remote. And then I have a file here that actually works with linear regression as a one-liner. I just leave it in there so I don't forget how to get linear regression to work and fit property work. And I'm going to be using logical regression very soon, and hopefully it'll work the exact same way. So we've got that tested, and that one's up and running. Then I took down a few notes on machine learning. It's kind of nice to start with. Let me move that over. Machine learning is found in almost every computer science, everything in computer science. They're going to show you 10 practical one-liners and apply them, these algorithms, to your own projects. It's the basics of supervised machine learning aimed to make predictions using existing data. A model is a black box full of data. The inputs are called features, denoted by variable x, and you get a predicted y out. And you just keep checking through these two phases. You're going to take a look at training phase and inference phase. And I've taken notes on those here, and that's making sense to me. The model, training your model, you model your desired output of y prime, so the change in y for x, and when y is output, you compare it to y, and if they're different, then you update your model. You're trying to get as close as possible as the y change that you're seeking. This is supervised. It's called supervised, and I've spelled it wrong. Supervised. That's probably a D because I'm thinking English American spelling. Supervised learning, dependent on training data, which supervises the machine learning process. And the inference is you use the training model to predict. I've got lots of typos here, but that's one thing in these tools. It doesn't give you the spell check. Output values for new input features X. Note, the model has the power to predict outputs for inputs that have never been observed in the training data. So that's the process that it's able to generalize, and that's for the main reason why machine learning is so popular in so many different things. It actually thinks somehow and figures out what it needs to do. So what I've done in here is I wrote out of the book a very simple script here, and we'll just take you through the script. I've got everything uploaded. You don't need all this other stuff, but I'm just going to leave it in because why not? It's running fine for me. So I set up an array 1, 2, 4, 9, 16. They look like squares, and then the length, it's going to give me back the length of that numpy array, which would be 1, 2, 3, 4, 5. And then I'm using this one-liner model, and keep in mind that I've brought in a scikit-learn linear model as linem. So I'm going to use the function linear regression. I'm going to fit it within a range n, and n is being driven here by the shape, which would be n by 1. You can play with the shape of those, but this is going to come out as 1 by 1, 2, 3, 4, 5. and you're going to use Apple as a model because that's the array. And then what I've done is I said, if there's 5 numbers there already, what are the predicted next numbers? You'd think it might think, okay, it should be like 25 and then 36, the square of 5 and the square of 6. It doesn't. It actually guesses them in, which is pretty interesting, at 21, 24. And so I'm just playing around with how this thing works. And if I wanted to go to, 12 and then think what the 13th item will be, you can go -2, which is kind of nice. Those are the predicted numbers. So you're starting to output data. Now, of course, this is still coming out as a type, and I'll show you here. This is still coming out as a type. If I run it, a class RPC Rhino Python core in net reference NumPy ND array. And so I don't know what to do with those things. Like, there's no comma here. I can't use it as a list. So what should I do? So what I thought was, let's do another one. Let's just make up another one and make it a little more parametric. Bring it in, then I can slide through. I've got the same kind of script going. And this is where I'm getting playful now in my scripts and adding to them. So I've got the same thing. In this one, I've decided 10, 20, 90, 160, 250. So I'm asking it to fit with those numbers. What would be, if I take a look at this, what would be the next positions if I was to guess at what they were? And I brought them in as X and Y now, so I can bring them in parametric. And I just took a positive and negative, so I can go in the positive and negative direction with this. And it's estimating that 5 steps out. If we think 1, 2, 3, 4, 5. Now let's go to the 6 out and 6 back. It's going to guess that where it wants to go, if it steps, it would go 134 in one direction, and in the negative direction, you'd end up with 390. And you can start using this data to kind of play around with these sliders to drive geometries. And that's exactly what I've done. Is I've gone in and I put it into a list item. I said, listen, I don't want all this information that I was pulling out. And I'm having trouble bringing this out to the A output. So I'm thinking, like, okay, try something like this, or try something like this. And these are things that I'm finding online in forums to try and get the data out. It's getting into the data trees. It's doing a bunch of funny stuff. I'm going through paths and the branch. And I got all into this stuff. I started to lose my mind over it. I was like, listen, I'm just going to deal with it out of the output. When it comes out in this form, I am going to, I think what I ended up doing was I took that, I found the type model. It comes out and says, okay, that's a NumPy array. But I said, well, what happens if I just pick the indices independently? Well, then they just go down to being floats. And once they're NumPy floats, I can actually see those outputted as data. I brought in the list. I decided, well, let's grab the list 2, -390, and the positive. So I end up getting both on there, and then I drove that into a circle. And if you think about it, that's then the circle that's provided here. And we'll just pop in my, we'll just jump in here. Sorry to confuse you, but I actually have a model up and running. So if you start to slide this through, you start to get these different radii of circles that's driven by linear regression. This is predicted circles where you would want them to be. Now, this is the most simple form of geometry, thinking of a radius. But this is where I'm going to start using this linear regression to drive some geometries and make some decisions. So I'm hoping people really get the connection, or what I'm conceptually doing in my head on the most basic prime level. But that's really where I want to do. I want to drive my data by this, and very accurate data at that, and predicted data at that. And so that could get more and more exciting as I go. Of course, I'm still having trouble outputting more. I don't mind outputting like this, but what I don't like in my scripting is if I start writing too much that's repetitive, I know I'm doing something wrong, and there's another way to code it. So I'll solve that. So when I got into all this nightmare, that's what slowed me down a minute. And I had to, I'd say, oh, hold the phone on that stuff. That got a little crazy. This one's slugging away. I said, I better go back into data branches and start to learn what all that stuff means as I try and control my data trees. So branch manager script is why I slipped into this nice script here, which was very basic. And this is one that everybody should start to learn about, of how to create and how to control their data trees. And it's actually just nested lists. I did a video before this one on that, so have a peek at it. If you have questions, just keep in mind that I'm finding all this for myself online. Nobody's teaching me it. Whoever hasn't, I'm not really in the forums too much asking questions. I'm finding the answers within the Rhino forums and Grasshopper forums. You can do it too. And the more you get into it, the better. And then I think, yeah, I read through everything. That's my little script to start. It's kind of fun. And I guess my script's a little bigger than it has to be. Let me slam it off to the side and pull it out this way. I think we'll have it more in line, nothing off the edge of the page. There you go. So Grasshopper one-liners, intermediate, advanced, taking a look at linear regression. Our next exercise after I plug through this linear regression, which I've already done. It's going to take us up the page about halfway through this book, which is very exciting, and we're going to jump into an example on logistic regression in one line. So we're going to do 10 exercises like that and be done this intermediate advanced section. I hope some people are benefiting from this. I'm putting it all on my GitHub. You can get it through my Patreon. I've got it in the $3 tier membership. I think it's well worth it if you can start considering the amount of files that I'm generating for you out of this text. It's a ton of work, and I'm enjoying it, and I'm learning a ton as well about data science, about machine learning, about tricks in Python, and I'm certainly scripting a lot more and getting my head around it than I ever was playing around in vanilla Grasshopper. Thanks very much for watching. Maybe one day I'll learn, keep my C going up, my C# going, and I'll be able to use the Rhino Common up and down and inside out. Thanks for